Good evening, mathematicians. Tonight we are going to be trying something a little bit new when we multiply fractions. We are going to be multiplying improper fractions. Let's see how it's similar and how it's different from just multiplying proper fractions. So here we have the problem, find the product of 6/5 and 3/4. So we know that word product, and I'm going to annotate the problem. We know that word product means to multiply. And there's lots of different ways that we could show this in an expression. And remember, an expression is an equation without the equal sign. So if I know that I want to find the product, I could write it as 6/5 times 3/4. And here we have our proper fraction, which means the denominator is less than, the numerator is less than the denominator. And 6/5 is our improper fraction. That's where our numerator is greater than or equal to the denominator. There's another way we could write this same expression. We could decide to write 6/5 times 3/4. Some of you may have seen that when we use an extra large dot, like a really big decimal, but right in between, that symbol means the same thing as our multiplication X symbol. So if you see a dot, just know that that means multiplication too. And what we also know about fractions when we're talking about multiplying is that we can say, what is 6/5 of 3/4? So there's so many different ways that we can show multiplication to find the product of 6/5 and 3/4. Well, let's start with our bar model. So here we have fourths, and what we know is that we care about 3 of them. So what we're going to do is we're actually going to shade in 3 of them. And we'll use our red color because that's what I underlined it with. So here's 1/4, 2/4, and here's our 3/4, okay? So if we wanted to find out what's 6/5 of 3/4, let's use our strategy of where we start with a simpler case. So something that I know, and this is going to help me figure out something that I don't know, is if I started with a simpler case, I know what 1/5 of 3/4 is. This is a strategy we've already done before. So let's start with that. If I wanted to know 1/5 of 3/4 and I wanted to represent it on my bar here, I would divide this model now into fifths. So let's make sure I have 5 parts. 1, 2, 3, 4, 5. Great. So there are my 5 parts. And if I wanted to know 1/5, if I just wanted to know 1/5, well, that would be quite simple. I would just take one of my 5 parts, and it would be equal to 1, 2, 3. 1/5 of 3/4 would be equal to 3 out of, well, how many boxes are there in the whole entire whole? Well, that was 4, and then we divide into 5 parts. We actually have 20 parts now. So 1/5 of 3/4 would be 3/20. But I don't want 1/5, so let me try and go up a little bit more. What if I wanted 2/5 of 3/4? See the pattern I'm going with now? Well, if I wanted 2/5 of 3/4, I would want these 2 boxes here. I would want these 2 holes. I'd want 1/5. Here's my 2/5. So now instead of having 3/20, this would be equal to 6/20, and we could simplify. Well, I think you can sense where I'm going with this, so let's continue the pattern. Here would be 3/5. Here would be 4/5. Here would be 5/5. Let's look at that for a second. 3, 4. If I were to write that, 5/5 of 3/4. Now 5/5 should jump out at you. You should be like, wait a second, 5/5 is 1 whole. If I wanted 1 whole of 3/4, isn't that basically saying I want all of the 3/4? Which is basically just saying it's 1 times 3/4. Anything times 1 is itself. It's the whole 3/4. But we have a bit of a predicament here. We don't want 5/5. We want 6/5, which means we are going to need to use another whole. So here's what we're going to do. We still know that we're dealing with 3/4. So even though we need another whole, we're still going to shade in our 3/4. So here's 1/4. Here's our 2/4. Here's our 3/4. But since 5/5 didn't help us solve our problem, it got us most of the way there, but we actually need a whole nother bar model to help us solve this. I'm going to use a whole nother hole and shade in the same 3/4. So 1/4, 2/4, and here's 3/4. And now we're going to do the same thing. Go back to basics. Start with a smaller case. Go back and say, okay, you know what? Let me just focus on making fifths for right now. And let's go and let's make some fifths. So here we have 1, 2, 3, 4. Okay, so let's go back and count. Here would be 1/5. That was 1/5. 2/5, 3/5, 4/5, 5/5. But we want 6/5 of 3/4. So we are actually going to need to divide our next one into fifths as well. And here is our 6/5. So believe it or not, we actually do not care about the rest of this bar model down here. We're basically just going to not pay attention to it. We'll draw all over it. We don't really care about it. What we only care about are these first 6/5 that I've put a green check next to. So if we actually count it up, and remember, it's going to be the ones that have double coloring on them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. We actually have 18. But what's our denominator? Well, to figure out our denominator, we would want to know how many parts we divided a whole into. Well, let's go back. We had 4 columns and 5 rows. So 4 by 5 means we had 20 parts in each whole. So even though we had to go into another whole, we're still keeping our denominator the same. It's still just 20ths. And how many had double coloring? 18. So the product of 6/5 and 3/4 is 18 20ths. And of course, we could simplify that to 9/10. Well, we've seen what we could do with a model, but let's see if that matches our algorithm. So friends, keep in mind that when you are multiplying improper fractions, you may need to draw another whole bar model and then give yourselves checks on the side. 1/5, 2/5, 3/5, 4/5, 5/5, 6/5, and then count how many parts are double shaded, and your denominator is how many pieces you had in one whole. Good luck! So we know there's lots of different ways that we can multiply. We can reduce before we multiply, or we can reduce after we multiply. Let's take a look. So since we have 6/5 times 3/4, if we were just going to do straight multiplication, we would do 6 times 3, which is 18, and 5 times 4, which is 20, which is 18 20ths. That's what we got before, and we know that it simplifies to 9/10. However, if we wanted to use our advanced new strategy of simplifying before we multiply, and we'll write it with our cool new multiplication dot, 6/5 times 3/4. Well, guess what? 6 and 4 can both be divided by 2, and our new numerator would be 3, and our new denominator would be 2. And if we now multiply, since we can't simplify 3 and 5, 3 times 3 is 9, and 5 times 2 is 10. So we ended up with the same answer for both.